So here's our board, and we're going to start soldering some parts on. Sorry about the viewing angle. I've got the camera on a tripod and I'm just trying to get in as close as I can. If I get any closer, I'm going to get flux on the front of my lens. So I've got some 0805 resistors in these packets, and I'm just going to start putting some resistors on. Again, I'm using the fabrication sheet as a reference. That's telling me where the parts go. So I'm going to start with resistors. I tend to start with passive components first. The reason for that is electrostatic reason. Once you've got resistors and capacitors in place, that sort of thing, and inductors, it means that when you come to put on semiconductors like the microcontroller, most of the pins will have a path to ground already through some sort of configuration of resistors on the board. I've got some 1Ks. Let's start with 1Ks. And I'm going to have to get some tools together, and I'm going to be using my tweezers just to get the parts onto the board. I'm also using very thin solder, it's very thin for surface mount work, and a very fine soldering iron tip as well. Let's have a go. Let's start with, let's see, a 1K. Did I pick out the 1Ks? Yeah, let's start with a 1K on the board. Can you see that okay? And let's start with R17, our first 1K resistor. So we need to get the thing out of the packet, which can be a little bit awkward. That's the first thing to do. Let's just get a, yeah, there's a 1K there. Turn it over. Okay, so that's our 1K ready to go into R17. So the way that I do it is using very thin solder. Put one blob of solder on one of the pads first. So here we are, we're going to go for R17, and just start it off by putting one small blob on there. So we need to take our resistor and carefully place it over the pads where you want it, and that allows you to solder the component in place. So let's just reheat the pad, drop that on exactly where we want it, and that's it there. So then put your tweezers on top of the component and just give it a light amount of pressure downward just to push it down. Reheat the pad, and what you see is the component actually drops into position, and that's it. So that's kind of into position. So now we can solder the other side. I hope you can see all of this like that. A little bit more, that's it. And then finish off by going back to the first pad again and just give it a little bit of a reheat with some new solder. And that is now R17, our first 1K, in position. Okay, let's do another one. Next is R16. So I'm going to do exactly the same again. Little blob of solder on one of the pads to start off with. Let's just put the little blob on there. This is R16 now. Okay, let's get another 1K out of the packet. There you go. And we need to turn them over. There you go. I'm cleaning the tip as I go, by the way, so making sure we've got a clean tip on the soldering iron. And it's a slightly awkward position, this one. I probably should have done it the other way around. I'm going to turn the board around, hang on. Right, now I can get hold of the resistor. And just like we did before, place the component exactly where you want it, over the pads, and then put it into place and heat that pad that we just put the solder on, and that will hold the component exactly where you want it. Put the tweezers on top, just give it a light amount of push down, reheat the pad, click. Sometimes you hear a little click. That's the component dropping down flat. Okay, that's now held in. Solder the other side, the other pad, that's it, and then go back to the first pad, apply a little bit of fresh solder, and that's it, done. So that is now, if I can show you that, soldered into position there. And it'll clean up once you get a little bit of isopropyl alcohol on there, bit of ISO, clean it up, get the flux off, and that's it. So there's two resistors done. That's the other one there, R17, upside down at the moment. Needs cleaning up. Okay, so who's next? Let's do another one. R18. Let's find him. That's R18 just there. I'm going to do him. Do him next. So there's R18. Here we go again. You know the drill by now. Little blob of solder on one of the pads, doesn't matter which one, just whatever's easiest for your angle of soldering iron. Now start it off with a little blob, and then get a new 1K out of the packet. There it is there, and turn them over. Okay, and just like we've done before, take the tweezers, heat up one side and place it where you want it. That allows you to sort of move it around a little bit if you wish. There you go. Then push it down slightly, heat up the pad, click, there it goes into position flat against the board. Then heat up the other side with some fresh solder. Solder that pad, go back where you started, fresh solder, that's it, done. Let's have a look. There you go, and there's R18, R17, R18 and R19. Luckily get them all in the same shot. Ha! Thanks to my macro lens that I've decided to connect up for the first time in years. So yes, there we go, 3 resistors in. All we need to do is keep populating and keep going. We were 1K, R18 and R17. See those? There you go. And I'm probably not going to do a time lapse. So let's just carry on, do a cut and hopefully come back with a few more parts on the board. I'll just keep going as I'm going. Okay, so I've gone ahead and populated as many of the components as I've got handy with me here. I'm going to have to order some more parts. I'm about halfway through roughly. So we've got a lot of the surface mount capacitors in as well, and the resistors, most of them but not all. You can see there's a few down here I've still got to do. I'm going to put the microcontroller in last. I've managed to put in the fuse and the key and transistor and the diode. Need some pots, of course. The trimmers need to go in, and a couple of chips as well. Yeah, it's coming along nice. Got to order up a 6-position dip switch. I don't actually have one in stock, and like I say, there's a few surface mount parts and stuff that I need to order. So that's as far as I can go in this segment, but it's looking pretty good. I think we're making good progress, sort of coming together. I'll come back and hopefully we've got everything on the board ready for some testing, haha, with power and whatnot. Okay, and we're back already, and we've now got the board fully populated. So I had to wait for parts to arrive in the post. As you see, it took a couple of days or so, but we managed to get all the parts that we need. The only part I didn't have was a 100K trimmer for the CW mute. I've had to put in a 50K just because it's all I could find locally, so I may have to change that. We'll see how it goes with the CW level. Might have to adjust it if it's too loud or if we can't make it quiet enough, that kind of thing. But other than that, everything else is in. We've got our dip switch in for channel selection, CTCSS selection. We've got the microcontroller, Atmel 328P, 16 megahertz crystal. The other trimmers, we've got an LM324, and we've got our 4066. All the other components are in, all the passives, the resistors and capacitors, and basically that is it. You'll notice we've got some headers here. Mentioned these earlier. This one's going to be for ISP, in-system programming. There's also a couple of pins on here for the comms, TX and RX. Got the fuse in, 500 milliamp, V-mid circuit up here. Got the connectors in. These are going to connect to sockets, if you like, wired sockets, which will plug into here. That's our final board. That's what it looks like, fully populated. The next thing we need to do, actually wire it up, see if we've got any computer access through the ISP connection, and start to test out various parts of the circuit. Probably do them individually, make sure that the CTCSS section is working by itself. So we're going to test it piece at a time before we put it in a box. And don't forget, this is actually going to connect to the 6502 board. So we're going to put these in a box and wire them up so they're both connected together. And we've been following the fabrication sheet. You'll notice I've got some parts on the left hand side here which are all ticked off as I went, just tick them off. So that's where we are. Looking good. Does it work? Ha! That's the next bit. So one of the first things I want to do is get some power onto the board. We're going to inject 5 volts to the supply rail. I've got a bench power supply here, not switched on right now, but set for 5 volts when I switch it on, and we can monitor the current as well. I've already checked for any dead shorts across the supply. Just did a continuity check, make sure there's nothing silly, and it looks fine. There's no shorts. So I think we're good to put some power on, and I'll do that right now. And I'm going to keep an eye on the amp meter on the power supply. Okay, power's now on. The current is milliamps. It's very, very low, which is great. Means we've got nothing bad going on, like high current situation or anything. I'm just going to probe a couple of points and just keep an eye on the meter and see what we've got. First, I'll just check what we've got 5 volts, so we'll do that right now. Okay, it's 4.8. I'm just going to increase the power supply slightly. Okay, try that again. 4.978, that's absolutely fine. So yeah, that's our starting point. So we've got a 5 volt rail. Okay, so the next thing I want to do is check the V midpoint, middle of the 5 volt rail. So we should have about 2.5 between the resistor divider, and we've got 2.495. Well, that's pretty damn close. So that's good. So we've got our V mid. So far so good. We've got power, nothing bad is happening, and we've got a V mid. So really all I need to do now is start maybe using the scope, see if it's oscillating, if the CW ident oscillator is actually oscillating. We need to check that, and then maybe, I don't know, maybe plug in the programmer to the computer and have a look to see if we can upload the firmware. Okay, so let's have a look at the CW oscillator output. I'm going to put the probe onto pin 1 of the 4066, and let's have a look, see what we get. Pin 1. That's it, pin 1 on the 4066. Amplitude wise, that's on 0.5 of a volt per centimetre, so it's 2 volts peak to peak. Quite a large signal. I dare say we don't need a signal that big, because it's, you know, it's going to end up being a microphone level really by the time it gets mixed and everything and reduced. Maybe the ×10 gain stage needs to come down. Don't think we need it to be like that big. But anyway, that's what we asked for, and that's what we got. So that is correct. Yeah, and the main thing is, well, here we are on pin 1 of the 4066 here, which is the CW input to the bilateral switches. And the main thing is, it works. So it's starting to come to life. It's starting to work. We've got V mid, we've got good power supply, we've got a sine wave oscillator. I guess the next thing to do is to check out the in-system programming connector and put some firmware into the chip, so then we can do some CTCSS checks and inject some audio and see if the little LED that we have on here, if you remember, we've got D2 here, little LED, and hopefully, if I've got it round the right way, because I didn't before, then that should light up when we get a detection, depending on the code we set for the channel select. Let's have a look at that. Alright, so we have the programmer plugged into the ISP socket. That should allow us to upload our firmware into the microcontroller. This is an Atmel RSIP, a RISP Mark II programmer. That's what I'm using. They're not very expensive. That's the connection we have. This is just USB back to the workshop computer. And I'm going to switch over to the work computer now, and we can have a look at trying to upload some firmware. But that's the connection at this end of the wire. Let's go to the other end of the wire. So here we are over at the workshop PC, the other end of the cable from the programmer through the USB cable. And we've got our firmware here. This has been modified with all of our CTCSS channels and what have you, and reading of the dip switches and whatnot. So this is all of the code here. I need to give credit here to Adrian, Y03, HJV, and ON4ADI and ON7EQ, ON7EQ there. So they're the original writers of the firmware, and I've just done some modifications, as I say, to make it read dip switches and whatnot for our purposes as a CTCSS decoder unit, kind of like a standalone unit. And it says which pins are connected to what and what have you. So this is the firmware we're going to upload to the chip. So what I should be able to do with a bit of luck is just click the upload button if I've got everything set correct. We're using the AV RISP the AV RSIP Mark II programmer, which is selected here, so that's all good. So I think we're okay just to click upload and let it do its magic. Let's have a look down the bottom. Right, it's trying to upload through the USB socket to the bootloader within the chip. Now the chip doesn't have a bootloader, so there's no way it can actually communicate through USB. Plus the USB is physically not connected to the to the port of the chip. So we need to select a different method, and we use upload using programmer. Control Shift and U. Upload using programmer. Okay, Control Shift and U. And I was trying to do it using the the USB serial COM port, which isn't even connected. So there you go. Right, I'll just do that again, and we'll look down the bottom. Upload using programmer. Okay, it's compiling. Do that again, and I'm going to see if there's any activity on the programmer. I believe it worked this time. That's strange. So the first time it didn't work, and the second time it did work. Maybe it was something wrong with the way that the state of the pins, or the state of the upload buffer. So I'm just going to do that again. Upload using programmer. Have a look down the bottom. So it's compiling first. Uploading now. Uploading. Done. Hooray! Right, that means we've now got the code in the chip, and it looks as if it's done it correctly after I selected the correct programmer. And now it looks as if it's done it. Okay, firmware taken care of. Let's go and have a look at the board, go back to the workbench, and see if we can inject some tones and get the thing to work. Okay, here we are back at the bench, and what I'm going to do now is try and see if the firmware worked. We've uploaded the firmware, at least we think we have. So let's inject a tone, a CTCSS tone from the IFR analyzer, and we're going to inject in 118.8 Hertz. So let's give that a try, just using the IFR as a glorified signal generator basically. Now before we can do anything, we need to look at the chart for our tone, which is 118.8, and this is the code. Now you'll notice that it's 010010 here, and actually the way the switches work on the chip, I've got on the right hand side, and I've got just the numbers on the left hand side, which means that at the moment all the switches are off. So that means because of the pull-up state of the chip, it means everything is high. So that's 111111. Okay, it's the opposite of what the switches actually are marked. You've just got to bear that in mind, that everything's inverted because we're using the internal pull-ups. When we make a connection on a switch, it pulls it to ground, it makes it into a 0. So an on means off. Okay, so just got to bear that in mind. So let's put the code in, looking at the chart for channel 18, which is 118.8. That's the one we're interested in, but we can check it for all of the channels later. So basically I want the opposite of that, 1 0 1 0 and 1. So okay, I think I've got that right. So it says 010010. We've got 101101. It's the inversion of that, which means that the code now should be getting presented to the chip. Now, if everything's working correctly, and you're saying this real time with me, I haven't tried this, so anything could happen. Let's put the tone on and see if the detect LED lights up. I'm going to do that now. Okay, I'm not seeing anything yet. I'm just making sure I've got everything wired up right here. Yeah, we are injecting tone into the discriminator input, which is correct, and that should be getting activated, and it's not. Haha! Here we go, you see. The power supply was switched off. I've got the power supply underneath my desk here, and I couldn't see the LED on it. Well, the neon. And I forgot I'd switched it off. That's how it goes, you know, that's how it goes. Right, we've now got power. we've put in the correct code. Let's inject the 118.8 tone, and let's see if this little LED decides to light up with a bit of luck. If I can keep my arm out of the way, let's try that. There it is. You see that? Ha! It's on. I'll turn my light off. There you go. That's our detect LED. It's actually working. Thumbs up. Yes. I'll take off the audio, and you see the LED's gone off, and I'll put the audio back on, and there you go. Absolutely brilliant. Now what should happen now, I'll put the light back on. When I adjust the detect level input, this should be able to turn the LED on and off as well with a bit of luck. Yeah. So fully clockwise is you need a big signal, and as you come anti-clockwise, you'll notice the LED comes on. So I'm just going to set it midway for now, but that's working great. So big thumbs up so far. CW oscillator working, CTCSS decoder working, and it's now programmable with dip switches. I can change the channel selection, which will just knock it out, and it should just turn off the LED. I'll go to a different channel. There you are. Now it's looking for a different CTCSS tone. Put that back. Perfect. So now it's fully programmable. It's exactly what we wanted. Let's see how accurate it's calibrated in terms of frequency response. So what I'm going to do here is, let's have a look at the IFR and select some audio frequencies. So let's go to tone, and I'm just going to go, I'm going to start going up first in what's 118.8, so it's in tenths of a hertz increment. So that's 0.9, LED's still on. Let's just keep going until the LED goes off. There, it's off now. Back one. A bit intermittent. Right on the point. That's 119.8 where it's flashing on and off. It can't decide whether it's on or whether it's off. It's having a hard time. Maybe as if we put some more input in. No, that doesn't really help either. So it's right on the border. That's exactly 1 hertz above 118.8. So let's go down. That's 118.8, and the LED is now fully on. I hope you can see that LED there. Trying to get everything in one shot. Let's go down until the LED starts to go off and flicker again. That's off completely. Go up one. There you are. It's flicking. 117.8. Can you see that? It's exactly 1 hertz plus and 1 hertz minus. Would you believe it's perfect? And you're seeing this real time with me. This is the first time I've tried it as well. And that's right on the border there. You can see it just can't quite decide whether it's a lock on or not. I'll put the signal generator back to 118.8, and we've got full lock. There you go. Brilliant. Now if you look at the logic output of that, I'll put the lamp back on. The detect output should now be low, which is this pin here. I'm on the detect output, and yes it is, it's 0.13, that's a low signal. If I turn off the audio and look at the detect signal, it should now be a logic high. And yes it is, 4.9, if I can keep my probe on. 4.9. There's our detector, fully working. Brilliant. So, real progress now. The only thing left to test on the board is really the audio switching with the 4066, and probably the keying transistor as well, though I haven't tested that yet. Although that's so simple, I can't see anything going wrong unless we've got a faulty transistor or something crazy like that. But the whole CTCSS decoder is working. The CW oscillator is working, although it has quite a high output. We may alter that a little bit and reduce it. I think it's going to be a bit bigger than what we need. And yeah, and we need to test out the switching. I suppose one way to test out the switching is to simply, let's connect in the 6502 repeater card and let it do its thing. Actually have a listen to it and see what's going on. I think we're at the point where we can just may as well wire the whole thing together and see what's happening, because we need to be able to switch the keying on and off anywhere. I could do it manually. We could stick a scope probe on the output of the switches and just, you know, key the PTT line, turn the oscillator on and off. That will check out whether the circuit's working. You could do it manually, but I'm thinking, why bother? We've got this far, everything's working. I think we're good enough to connect in the card and give it a try. Let's do that. One last test before we leave the decoder alone. I'm going to put the scope onto the input of the microcontroller. In other words, the digitized signal after all of the low pass filter and everything. So we can tell whether the low pass filter is working if we sweep the input audio frequency. So let's put that on the input pin. You'll notice we've got a digitized signal coming in there. That's to the microcontroller digitized signal after the low pass filter. And at the moment I'm on about 70 Hertz. So I'm just going to rapidly scan down. That's like 20 Hertz. You can see it there, 40 Hertz. Okay, well that's below CTCSS tones. So I'm going to scan up. That's 200 Hertz. Okay, I'm just rapidly jumping up here. And there'll be a point, you can see it's starting to disappear. It's getting weaker. We're up to 280 Hertz. And by the time I get to about here, it's pretty much gone. 330 Hertz, which is correct. If we go any higher, there you are. That's 390 Hertz, it's completely gone. Come back down again. Just starts at about 300 Hertz there. And as it comes down, you get a bigger and bigger signal. That's 200 Hertz. And if we go to 118.8, which is about there, nice clear signal. So, confirmed, the low pass filter for the CTCSS decoder is working perfectly. Right, so here we are. I've connected up the 6502 controller card through these wire links here. Hope you can see all this. And multicolored spaghetti going on. And to the audio card. And here we are. I'm injecting the sub-audio tone separately because that's going to come from the receiver eventually, from the one of the outputs of the receiver. It has a dedicated discriminator output which gives us the sub-audio tone. And we are also looking at the audio out. Now that means when the repeater switches on and keys up, in other words, we've got an activated tone and we've got a squelch line, once those two conditions are satisfied, we should get CW out of the scope. So let's go and have a look at the scope. And I'm going to just like manually put a wire on here just to set it off, to trigger it. Right, so first I'm going to put the CTCSS tone on. That's on now using the IFR 118.8 Hertz. And now I'm going to trigger the squelch line as well. You need both conditions to be true. And there you go. Da 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 da. That's my call sign. And you'll notice the pips are much bigger. And when it finishes, you should have high amplitude CW ident. There it is. Now I'm looking at the waveform. It's not particularly clean. Nasty sort of jumps in it and stuff. I think we've got too much gain going on. What I said earlier about the oscillator signal being too high, I think we need to maybe change one component and reduce the gain coming out of the audio coming out of the oscillator. I may have to investigate that, but for now, let's just do a big thumbs up and say it's working. We are getting keyed CW from the controller. So now the controller card is actually controlling the audio card. So that's the first time it's actually being wired up in this configuration. First time I've seen it working. So the only part that I haven't tested is the audio in. I'd have to inject audio in, and I'm probably going to do that just by connecting it to the actual radios themselves. We'll do a final check and calibration of the trim pots. See if our 50K trim pot is big enough, or whether we need to actually really go for the 100K or bigger. Does the CW mute or CW level reduction, is it enough reduction? I don't know. So we need to just like try it and see what it sounds like and adjust for best audio quality. The only thing I haven't retested is the TX. Probably can test the TX if we just put a meter across the PTT line and then allow the repeater to go into transmit. We should be able to see that on the meter. So let's just do that. Okay, so I need like too many hands to do this. I'm going to have to put my probe on the PTT line, see if it's actually in transmit now or not, and it should not be. So that's the PTT line, and there's nothing there. I hope you can see that's infinity there. So there's nothing there. if I put the whole thing into transmit by putting on the CTCSS tone, and we can inject the and then we could trigger the squelch line. Yeah, we've got CW on the scope now. Let's look at the PTT again, and there it is, 0.002. That's volts across the collector and emitter of the keying transistor. Now it's about to time out. Wait for it. There you go. And it's just timed out, and now it's gone high impedance again, which means that would have turned off the transmitter. So we've just checked the keying transistor, and that's working too. I have to say, so far we're doing pretty good. There's no major problems or anything. So quite, let's just say, relieved at the same time doing this on video. So, you know, because things can go wrong, and you've just got to be prepared for that. If something goes wrong with your design and you come to test it like this, and it's like, something's not working. It can happen, you know. Up to now, no faults. Everything's looking good. Maybe just reduce the audio level from the CW oscillator, like I said earlier. Got a bit of distortion going on. Looks like it's just too high, too much signal. We'll knock that down. But so far, everything's working. Okay, so moving along nicely here. Now that we've actually tested the cards and, you know, make sure that they're electrically correct as far as we can tell, without connecting them to radios yet, but by doing all of these separate section tests, looks very good. And I think we can proceed with a reasonable amount of confidence. So, I found this. This is a project case, and I forgot I had it actually, so it's quite nice. It's never been used, so I'm thinking, I think it came from RS originally, and it's even got like a sealed gasket around it as well, so once it's closed you don't get any moisture in, which is nice. Not that it'll be operating in any damp environments, but it's good against weather, damp air. And what I'm thinking is, it's nice and shallow, and we could easily, looks like a router, that sort of size, you know, like a sort of a router box. What I'm thinking is we can put all of the electronics in here, maybe have some fancy LEDs along the front, or on the top, power indicator like +5, detection LED, squelch LED, TX. That should probably do it. Probably 4 LEDs maybe, something like that. And on the back we're going to have maybe connectors, a couple of D connectors, or one big D connector with a breakout cable. Make it like a small loom which connects to the radios perhaps. Could do it all on a single 25 or even smaller, maybe it's even a 9 pin. Figured out that in a moment. So that's what I'm thinking, and inside we can place the boards like so. I've also got a little buck converter which can take 12 volts or whatever voltage you like down to 5 volts regulated, and this can supply up to like 2 amps. You get these off eBay, they're very, very cheap, or Amazon. So I'm thinking, right, we'll put that inside, in here as well. So we've got the 2 boards, and we've got the little buck converter from, it means we can drive the whole thing off the 12 volt supply. Put a connector on the back for 12 volts. Means we don't need a separate power supply for it. That'll take our 12 volts down to 5 regulated. So it means we can run it off the same supplies as what the radio runs on, which is a, you know, typically a 12 volt. Certainly in our case it's going to be a 12 volt power supply. Quite simple. So that's kind of what it's going to be looking like. I've already mapped out, just using a black marker pen, I've already mapped out where the mounting holes are, just by placing the board, move things around and just sort of go, okay, that'll do, roughly like that. Mark out the mounting holes with a marker pen, and we're going to drill that. It's an M2.5 hole I need for all of the little nuts and bolts and little like standoffs and that sort of thing. And then we can mount everything into the box. So I'm going to do that first before I decide where I'm going to put connectors and LEDs, whatever. But, you know, we've got plenty of space. Don't know what to do with the top. Could print a thermal label which would have legend for what the LEDs do at the front. Maybe have little icons there or something, or connectors, you know, marking out the back. We've got plenty of options to play with, but it would be nice if we can finish the whole video series by having the thing in a nice little box and running off 12 volt supply, and then we can plug it into the radio and we could try the whole thing. So that's what we're aiming to do. So that's the idea so far. Drilling some holes. That's the holes drilled for the boards. Just seeing if I've missed anything. Okay, let's get the boards in. Okay, so that's our holes drilled in for the positions of the boards there. And all I'm doing now is putting nuts and bolts in to create standoffs, M2.5 holes that I've just drilled. And I'm using these little threaded standoffs, so they just go straight onto the board. Tighten them in. And I've got my little mini ratchet thing, so we can just give that little nip up. These are just plastic ABS boxes. They're quite tough once the lid's on and everything, but you don't want to over tighten them, we'll probably just crack them. So just give them a nice firm nip up. Yeah, that should do it. This will probably have feet on by the time I'm finished. I'll put some rubber feet on to lift it off the table or whatever you put it on. Right, so I'll keep going. I'm going to populate all these holes with these standoffs, and then we should be able to put the boards in. And just like that, quick as a flash, with the joys of video editing, here we are with all the standoffs fitted. Theoretically, we should be able to put the boards in, as long as my holes are in the right place, of course. Now, when you're doing things by eye and marker pens, you know, you could be half a millimetre out. It can happen. It just depends on how careful and how methodical you are. If you take your time and be sensible about it, you could actually get them exactly right. I'm kind of rushing a little bit here just to get the thing done. But let's see if the board fits. And if it doesn't fit, it's just plastic. It's very easy to just slacken off, you know, one of the screw heads and just kind of like move it around a little bit and then fasten it back up again. But let's see, let's see how good we got it. So I'm going to take the analog card first. Let's just see how close we are. How's my drilling skills today? Oh, it's close. Two of them's in. I reckon I can just push that a little bit. Yeah, I'm slightly out on that one. Oh, that's a pretty close, that. So what I need to do is slacken that one off. And he's a bit too tight as well. I'm going to end up destroying the board if I'm not careful. So that needs to be slackened off. And that one as well. And we'll just try that again. Now it's in. I guess the best way to do it is just leave them slightly slack to start off with, and then when you're finished and you got all the boards in, then just tighten them up. Perhaps that's the better way, yeah. So there you go, and I can just tighten that up with a screwdriver now. The good old 6502 control card. How does this fare? How's my drilling skills today? Ooh, same again, slightly out. Okay, I need to slacken a couple off. The ones that's a bit too tight. You shouldn't really have to push them through the holes too tightly, because you'll take away the solder of the through plate hole. So you don't want to destroy the board or hurt the board in any way. So that's it, that's in. So yeah, it's coming together. They're almost in line. It's pretty close. I'm just doing this by eye. I'm not using any tape measures. I'm just dotting it out with a marker pen. And it gets you within about half a millimetre or less, so it's not too bad if you take your time, like I said earlier. That's coming together. These can be re-tightened. We've got enough thread on the top of the bolt there to get the nut on, so it's sticking through far enough, so that's good. What about the buck converter? Yeah, now the buck converter actually has M3 holes, so I could actually put M3 bolts in here, but all I'm going to do is use these M2s. M2.5 rather, and keep them all, you know, keep them all the same. And there you have it. Looking good so far. Yeah, so I'm just trying to make some decisions about what connectors to put on the back of the box, and I've come up with this scheme here. It was going to be a choice between a D-sub 25 or maybe it's even a D-sub 9. Let's work out the pins that we need to connect to the radios, see what we can get away with. And don't forget, it has to fit inside of the box, so we've got space. We could easily get a 25 in there, but we could even put a 9 in, so we can get a 9 in as well. So looking at the pins, we need a microphone line for the transmitter with its own ground, because that's going to be like a mini coax. PTT with a ground. The ground also acts as a ground for the squelch or busy line. The discriminator output from the radio, we've tapped into the radio receiver and it's got a dedicated output. That's going to drive the CTCSS decoder, its own ground as well, so there's another 2 pins. And we need audio out, which is the actual speech output from the radio. So that's the scheme, and as you can see, it fits perfectly onto a D sub 9. So we're going to put in a D sub 9, and that's going to go in the back, in here, and it's going to be wired to the various cards. I've also got a standard 12 volt DC plug-in socket. It's got a couple of mount holes there. I'm going to put that on this side. That'll go in there. That means we can just plug into the back with our 12 volt lead. So we're going to end up with 2 sockets. Quite simple. Should be pretty neat when it's done, hopefully. So the D sub 9, going to have to make a loom, like a wiring harness. I've got a nice fancy red shell for that. So that'll plug into there. The wires coming out of here will go to the various connection points on the transceiver itself. A little bit of wiring to do, like I say, just to make sure everything connects to where it needs to be. But generally, that's the plan. Just making the hole the right shape. Takes a bit of filing. I've just finished filing this hole out. If you can see that. Took about 10 minutes. It's a little bit labour intensive doing these things by hand, but this is now the right size. I can just put that in and it actually holds it. So the hole's exactly right. So what I need to do now is get a couple of pilot holes there, and that'll hold the D sub in perfectly. Look at that. Good fit. D sub in. Next thing is the power connector. Yeah, so I've just temporarily put the controller card back so we can see where we're going to put the connector down here. Offer it up, have a look at the position that we're going to put it in, just in there, and make sure we've got a bit of a gap behind it. It should go in there somewhere like that kind of thing. Yeah. So yeah, I've got a little mark there, and we're going to do a pilot hole and then get the right size hole. This will go on the inside and we'll just be left with a hole. So the hole has to be big enough to take the whole plug. Make sure the whole thing goes all the way in. So the plug's actually going to go through the wall of the plastic and the whole thing will go in. So we need a reasonable size hole. So I'm going to do that right now. And we'll just go for it. Doesn't have to be too precise at this point. That's it, simple as that. Plastic's not very hard, and I've got it reasonably where I wanted it. Okay, so let's keep going. I'll go to a 5 for now. Okay, just grabbing the bit a bit there. Yeah, I think it's going to be an 8 or a 9. I'd better take it easy and go for an 8 first. Of course, I do have a step drill. Ah, that's a better idea. These are handy. Step drills. You can get any hole size you like. Let's do that way. Let's have a look. What have we got? Okay. Now the good thing is here, you can just stop when you've got so far and see how you're doing. Now I need this to go right in. Okay, next step. There you go, very easy now. Ooh, it's pretty close. Don't want to make it too big. No, it needs to go all the way through. That's it. That's the one. Plenty of space there now. If anything, it's slightly too big, but I'd rather have it that way than too small. Right, that's good. So now we need to do the holes for the rest of it. So now we just need to mark out where the screws go on the case. Do a couple of maybe, I don't know, 2mm holes, 2.5mm. That should go straight through. Right, back in a sec. It's in. I'm just going to tighten it up. Reasonably centre, if you can see that. Looks. It's not exactly in the centre of the hole, but that's why I wanted the hole a little bit bigger. And that is in. That's it. Goes all the way in. all the way to the inside of the connector there, so that's perfect really. Job done. Coming together. I haven't decided what LEDs and indicators and things. If I'm going to do it, I'll probably put them on the front. I think it'll look quite neat. Goes off to the side a little bit. That's because the kind of goes that way a little bit, and that goes that way. It's because there's a slight curvature in the case there, so that kind of goes that way a little bit, and that, that goes that way. But I'm not bothered about that. Let's just keep that between you and me and the internet. Right, onward. So next thing is clean it all out, because I've got dirt everywhere, as you can see. I'm using a towel here just to protect my ESD bench. I think we're done with holes for now. Don't know whether to bother having a power switch or not. I might put in a power switch, I don't know. But with it being a repeater, you kind of want to just have the power on all the time. You don't want anybody to knock the power off. So I'm in two minds whether to bother with a switch or not. Maybe I will, I don't know. One thing I did think of was the controller card only resets when you power up, and I'm wondering if I should tap into the reset line on the 6502 and then put a button on the front, so if for some reason the repeater gets into an unknown state or something, maybe there's a power problem and it comes back on again and it's locked up, you can just hit that button and it'll reset everything. So I think that might be a good idea, just to, you know, make sure that it keeps operating correctly and we can reset it at will. So yeah, that's a possibility. Again, we can just add to this as we go. Get the boards back in. I think we might actually start wiring this thing up. Like I say, indicators, I think I'm going to leave them for now, unless I can find something in my junk box up there. And if I've got some handy, then we'll stick them in. I've gone ahead and wired up the power connector to the buck converter there. Added a little fuse for now. This may get removed, possibly fit a proper fuse in here perhaps, or like I said earlier, just put it in line. But I'm thinking, because this now runs on a variety of input voltages because of the buck converter, we could run this off pretty much any DC supply as long as it's higher than 5 volts. Anything above 7, 8, 9 volts, something like that. So 9 volts, 12 volts, 16 volts, anything like that, we can plug it in and it'll just take care of it. So we've got a variety of supplies we can plug in. It's pretty good. Next thing I'm going to do is start wiring up the boards. We need power for both boards back to the buck converter outputs, which is up here. Start making some connectors for these. Now what I've got is some small connectors here. These are the shells, and I've also got pins, well actually female sockets if you like, and a crimp tool. So with a little bit of practice, you can make your own wiring harnesses, and that's how I do it anyway, rather than using the ones you might have saw earlier on, these DuPont connectors. And you know, you can just sort of plug them in. It's not very good. It's okay for prototyping and testing, it's fine, but for an actual internal wiring job, you want to do something a bit more sturdy, a bit more solid. Let's make our own connectors, and it just so happens, I've just realized, how's this for luck really? This shell is exactly the right size to fit all of those connectors there, including the power. So it does all of the card connectors and it does the power. How about that? So all I've got to do is really populate this. There's a couple of spare pins in the middle there. Use that as a key slot perhaps. Yeah, so that's worked out really nice. So I can crimp wires onto that. I'll just pull out. I've got like a variety in here, just a selection box of DuPont connectors, of shells, you know. Probably need the next size up. Let's have a look. Is it that one? Anyway, I do have a one that'll actually fit on the CPU card as well. I'll just have to find it. So, but yeah, the good news is the big one fits right across there. Really happy with that. That's a bit of a happy accident. How about that? Sometimes these things happen. Like finding this box, which I forgot I completely had in the store cupboard there. So yeah, you know, if you've got enough things lying around, I guess, you know, it sort of works. Right, so let's make some connectors using the crimp tool, and I'll come back, we'll do some wiring. Yeah, so let's have a go at doing one DuPont connector. So I've got a little red bit of wire here, which is going to be my positive for the control card. It's going to go in there somewhere. What I'm going to have to do for the control card, I don't have any 8 wide headers, so I'm going to have to use 2 4 wide and put them next to each other. So let's make a connector. So I'm using a crimp tool to fit the DuPont connections, and first of all just strip the end by about, I don't know, 3 millimeters, something like that on the end of the wire. I'll try and get a bit closer, hang on. I think I'm about there, about 3 millimeters, something like that. Then you take one of these, the actual, if you like, the conductive part. It's actually like a female collar, and just chop one off the end like that. So now you've got that, and it's got like a little sort of like a T shape, if you like, and that's what's going to go into the crimp tool. You also have to figure out which jaw you have to use. It takes a little bit of practice to get the whole thing right. I sort of wasted a few pins when I first bought the tool, you know. You just have to have a bit play with it, and then eventually you sort of get like a feel for it. And I'm just pre-bending these little wings here, just a little bit, and it goes in the crimp tool easier. That's it. I'll show you this in a second. So I tend to close the jaw so it's just clicked on its first click, and for these particular pins we're using jaw number 3. So you put and then close it up slightly. I don't know if you can see that, but I've got the pin in there, and it's just kind of sitting on its edge, butted up towards the jaw. So that's the pin in there, and it won't go in any further. Like I say, it's stopped by that sort of T shape. Take the wire, our positive, push it in till it just appears on the other side there. You don't want too much wire, and then give it a good crimp, and that's it. So that's now on. You see that okay? That is now on, and it will not pull off. The only thing we'll have to do now is remove that back T shape, and now all I do is I just twist it like that, and it just comes right off. And that is our first pin. That can then go into a shell, and as I say, it's going to go into, I don't have any 8s unfortunately, that would have been neater, but I'm going to use 2 4s next to each other. So looking at the board, you can see the positive is the second pin, so it needs to be into the second pin, and all you do is just push it in. You see that okay? And you might hear a click if you're lucky. Hang on. You didn't really hear that, but it's now in, and it will not come out. And that's it. That's the first one done. Now we've got like loads of others to do. I'm obviously not going to show you them all. It'll take far too long, but you get the idea. So these crimp tools are excellent, and you can, I think that was about £16 or something off Amazon. This one is a Perceiver. That's what it's called in here. It's a PR3254. PR3254. That's what I bought, and it works great. And you have to buy, like I say, you have to buy the pins separately. And these are, you get male versions. These are male ones, which to be honest I hardly ever use. And you get the female ones, which is what we're using. I'm probably going to have to buy some more. Let's continue. I'm going to make up the wiring harness, get this all connected, solder it to the D connector and everything. Let's get this thing done. Here we are. It is wired. Got the connectors all in now. We've got the perfectly fitting DuPont connector here. This is all wired to the D connector at the back. You'll notice I've got some twisted pairs here. I decided to do it this way rather than coax. It's a short run. I don't really see the point in having coax. It's only about 1 inch or something, 1.5 inches max. I thought I'll just twist them with the grounds, and it'll give it some sort of like noise rejection in there. The other connections go underneath here, and these ones here, and that comes through to the controller card. As I mentioned before, I've used 2 4 in 8 inline there, DuPont there. So the power's connected, power comes through here, and it goes to the output of the buck. Both boards are supplied separately. That kind of should be it. I think what I need to try now is power it up through the 12 volt input there. Just do some quick checks, make sure everything's powered up correctly. And the last thing we need to do, apart from put the lid on and think about if we're going to have LEDs or not, probably will, it'll be nice, is to connect up the D-sub to the radios itself. So we need a little bit of a wiring harness to get to the actual radio from there, but that's external to the box. So here we are, wired with our little DuPonts and everything. And I'm going to put some cable ties around these just to sort of like cable tie it down. I haven't bothered quite yet, but when I come to finish the whole thing, this will be a little bit neater, and just cable tie it up, generally make it a bit more solid, a bit more robust. There we are. That's basically what we've got so far. I think it looks okay. I think I'm going to power it up, do some quick checks, and then we're going to look at actually wiring this up to the radio. Okay, here we have it. It's all wired, and what we've done is completed the wiring harness to the D-sub, to the radio, and I'll show you the overall connection system that I've got here on the bench. So let's take a look at that now. So what we have is the duplex radio. It's operating on 2 bands at the same time, full duplex, 70 centimeters and 2 meters. So we've got, if you like, 2 radios in one here on different bands. One's transmitting, one's receiving. We've got a connection here through the little harness thing I had to make, which taps into the discriminator output on the receive side, and it also does TX and audio and that kind of thing. Comes through these wires here to the D connector, and that connects to all of the boards inside. I've got a little handheld radio here, also a duplex, which runs on 2 bands, which is basically communicating to this radio. Haven't got round to doing LEDs on the front yet. That'll probably come last when I've got a bit more time. But for now, I just wanted to see if it actually operates. So we're all powered up, the radio is on. I'm using a dummy load on the transmitter, which means there's no aerials connected, so nobody's going to actually hear what we're doing here. We're not radiating any sort of appreciable energy or anything like that. And I've got a little dummy load into the handset as well, so it's not really, it's only going this far basically, that's it. Let's transmit on the transmitter, and hopefully you might see an LED come on in here if you see the detect light, if you can actually see that. So let's key this up. And absolutely nothing. It's not even plugged in. Right, try that again. So let's key this up. I've got a bad connection. Yes, I have. I've got a bad connection going on. I've got a wonky bit of wire here. Well, we're getting a detect light, but it's not actually coming on. I think this needs a reset. The 6502, it only resets on power up. I've got a bit of a bad connection, so the supply's been going on and off. I think there's a chance it's in a non-reset state. It could have actually crashed even. So I'm just going to pull out the power and reset this. I need a better reset on that. Right, put that power back on again. Let's just try that again. There you go. And we can hear it. That's now in transmit. 1, 2. It's feeding back. Sorry about the noises. Yeah, it's working. It's working. Got a bit of a problem with the reset circuit. Turn that down a bit. That should go to receive. That's it, gone to receive. Try that again, key it up. There you go. That's working. One, 2, 3, 4, 5. Yeah. Excellent. CTCSS decoder working. Everything doing what it's meant to do. That's it. Right. So the things that I've just discovered is I've got a bad power lead. Can sort that out. The 6502 card, the processor card, seems to be very susceptible to power problems. I've just noticed that because of that bad connection. I think we're definitely going to need a better reset circuit on that to make it a bit more robust. That all aside, hey, it's all working. Didn't even need to adjust anything yet. Do some fine tuning. make sure that the deviation's correct from the transmitter. We can alter all of the levels, make sure the CW level and the muted CW level is correct, it sounds right. The CW pitch sounds all right. I think we're around about 700 Hertz, maybe it's a little less. Keying transistors all working, it's going into transmit. I think we're pretty much done. We could even think about putting the lid on. That's always like a final step when you come to put the lid on. Would be nice with some LEDs. We need something on there, don't we? But let's try that once more time. Just key that up. Yeah, that's cool. 1, 2, 3, 4, 5. And every 10 minutes that will give out a beacon ID. You've seen all that in previous videos. I'm not going to go through the whole thing again. But here we are. We've got 2 customized PCBs in the box. Retro 6502 just for the sake of it, because it's fun. Really, this whole board could be replaced with a small microcontroller. We could make it programmable through an ISP connection, just like we did with the audio card, and make it surface mount. These cards could be exactly could be made exactly the same size. Make it firmware programmable, which makes the software much easier to change. At the moment, we're writing everything in assembler, 6502 assembler, and we're having to put it into this EEPROM. It's all very 1980s, 1990s technology, which makes it fun. Well, absolutely didn't have to have a 6502 in here. You know, it could easily be replaced, and probably, maybe even one day it will get replaced. And we'll do another card with a microcontroller, very much like in the audio card. How about that? Working repeater in a box, customized PCBs. I think we're going to put an end to this video. I'll put some LEDs on the front, power, detector for CTCSS tones, squelch line or busy, same thing. I don't know. What else? PTT for transmit, so when the radio goes into transmit, we'll have a nice little LED on there. You know, there's all kinds of things. There's even a little bit of room on the lid. It's pretty shallow on this particular box. We couldn't really mount much in there. It would have to be something very shallow, like a display or something. I was thinking maybe it's like a nice display in there, but it would have to be very, like I say, very shallow. I hope you've enjoyed the process. It's been quite a long process. I know I've got multiple videos here of designing boards, using KiCad, you know, doing a bit of firmware, uploading to chips, that kind of thing. A little bit of hardware, put it in a box. What you've really seen is the entire process, at least my process. It's not necessarily everybody else's process, but that's kind of how I'm doing it. And I hope you've got something from all of this. It doesn't really matter that it's a radio repeater or not. Maybe you're totally not interested in radios. Maybe you're more interested in audio circuits or musical circuits or, you know, synthesizers, anything like that. Maybe you're not really too interested in radios, but the processes are the same. And, you know, you do your schematic, maybe make a prototype like what I did. If you remember, we had this board here, which was the prototype version. That more or less is what's in here. This card here is basically all of that. So you can see it's quite a reduction. That's what we had. All of that is that card there. So, you know, you can build things like that, and with a rat's nest of wire on the bottom. It's ugly, but you know what? That actually worked. And it proved that the circuit was worth continuing with. We managed to make a few tweaks to the circuit, you know, change a couple of component values and implement it into the final schematic. Once we had the schematic, we could then produce a PCB, decide what footprints we want for all of the components. In this particular case, it's mostly surface mount, 0805 footprint, with a few through-hole components on there as well, like variable resistors, trimmers, you know, dip switch and a fuse, that kind of thing. But mostly, probably 80–90% of it is surface mount, as opposed to the 6502 card, which is all through-hole, because we wanted to make that sort of retro. I think that's going to be the end of the project, and I do hope you got something from the whole process, like I say, from concept right through. And all I will say is that these are the original cards right back at the beginning, which are designed and made back in 1986, I think. And you can watch earlier videos where I reverse engineer my own work, because I lost all of the schematics and all of the diagrams. So this is the controller card, again with the 6502. and that's the new version here, and this is the old analog card, and that's now been replaced by that card there. So I hope you've got something from all of this, and I just want to thank you all for watching. If you enjoy this kind of thing, then give us a thumbs up, and don't forget to subscribe. Go back and watch the previous videos to this if you want to know how we got here. There's a bit of a story, and well, I just wish you well, and hopefully see you on the next video. So all the best and goodbye.